Okay, we're going to look at projectile problem test review number 1. This one's going to be like the old ones we did a couple weeks ago, where it's just a object going off of a surface, like ball rolling off a table or something like that. So we're reviewing that. Test will be on Friday on this stuff. So we want to go over this again. I'll give you 3 problems like this, and then there'll be some multiple choice questions that you'll also receive that we'll go over as well. So I have 10 multiple choice questions for you to look at later too. Remember on the ball rolling off the table, so this first one we've got 22 meters per second. It's a 9-meter high cliff, and we want to know where the ball is going to land. Remember, the first thing we want to do is draw a picture of the situation. So I'm going to make this fairly small. There's my 22 meters per second that the ball is rolling. It's going to fall on a projectile path and land here. They told us that the height was 9 meters. And they're asking us to find out x, how far away that is. I'll slow down, so if you're writing this down, you can. Remember, we separate this into horizontal and vertical, given and find. So my horizontal information is going to go here. My vertical information is going to go here. First thing I write is what is given, and in this case, I'm given a speed in the horizontal direction, and I'm given a height in the vertical direction. And remember, I am always given the acceleration in the vertical direction is negative 10 meters per second squared. We want to write down what we're going to find on both sides, and then what equation we're going to use to solve that on both sides. And so if I look at what's given in the problem, I've got a speed that's in this direction, which is horizontal. So I'm going to put v is equal to 22 meters per second here. They've also given me this height. So I'm going to place that in my given over here, y equals 9 meters. And what they're asking me to find is the horizontal distance or displacement. So I'm going to be finding x on this side. Remember, once we do that, find x. What's the rule? We find time first. So I'm going to go the other side, and I'm going to find time first, t. And then the equation that we use that has a y and a g and a t in it is, of course, y equals 1/2 gt squared. So I'm going to plug in what I know. It's going to come down negative 9 meters, remember. Half of negative 10 meters per second squared. I'm solving for t squared. Negative 9 meters equals negative 5. T squared, we're going to divide by negative 5 on both sides. I'm going to get t squared is equal to 9/5. We'll find that out in a decimal. 9 divided by 5 is 1.8. And then I'm going to take the square root on both sides to get t. Square root of 1.8 is 1.34 seconds. Okay, so once I know that, I'm bringing that up, and that becomes part of my given on the other side. Remember, time is the one thing that's the same on the vertical and horizontal side. Okay, whatever time it takes to fall the 9 meters is the same amount of time it's moving forward for this distance x. My equation on this side is almost always x equals velocity times time. It's the x velocity, of course, as it's moving in the x direction. And I take 22 meters per second times 1.34 seconds. I forgot to write that up here. Plug that into my calculator. I get 29.48 or 29.5 approximately. There's that first one. Okay, so you will have a problem like that. I know we already took a quiz on it. I'm going to put one of those on there just to get you started. That's kind of like the most basic one that we have in that. I'll leave that there just for a minute in case you're jotting it down. But you can always go backwards in the video if you need to. Okay, question number 2 then There is no angle. We have not done these in a while, but we're doing ones where things are launched at an angle. In this case, we're just going to throw something straight up in the air. Okay, so they tell us I've got a ball that's thrown vertically into the air with an initial velocity of 38 meters per second. So here's my surface. I'm going to throw it upward at 38 meters per second. And the first question says, when will it reach its maximum height? So a little bit different than the ones that we've been doing this week where they go up and down. And I've asked you what's the total time in the air. This time I just want to know how long does it take to go up. We've done that a million times before. If this is 38 meters per second, the acceleration due to gravity is 10. So the speed changes by 10 every second. It's going to take me 3.8 seconds to reach this maximum height at the top. Okay. Should be able to do that by now. And even if you haven't seen these in a while, we've been doing that with the up and down projectiles that are moving horizontally as well. Okay. Number 2 wants to know how high the highest point is. So remember how we consider that. How high is highest point? Instead, we're going to ask the question, how far will it fall? And now I'm going to be using again my falling equation, y equals 1/2 gt squared. It's going to fall back down for an additional 3.8 seconds. 3.8 to go up, 3.8 to go down. Remember that, we've done that before. So my y here should equal 1/2 -10 meters per second squared times 3.8 seconds squared. And I get y equals -72.2 meters. Again, it asks how high it is. Obviously, I'm going to get a negative answer because I did a falling equation. It's coming down for its displacement from up here to down here. But we know that the height then would be positive 72. Again, I don't care what answer you give, positive or negative. As long as you get the 72, we're good. Okay, question after that then says, how fast will it be going and how high will it be at exactly 4.80 seconds? We've got 2 ways to do these. The first one is mathematical. Just look at what you're given. You are given a time 4.8 seconds now, not 3.8. You're given an initial velocity of 38 meters per second. Okay. And we know the acceleration due to gravity anytime it's in the air is still g equals -10 meters per second squared. We're doing something similar to this, except it does have an initial velocity now. When we let go of it up here, and again, this is why we do how far will it fall, it starts with a speed of 0, so we don't have a v naught t in this equation. But over here we will. So we're going to use y equals v naught t plus 1/2 gt squared. I'm solving for y. If I throw it up in the air going 38 meters per second, I want to know at a time of 4.8 seconds what the y position will be. So I calculate that out. Y equals 38 times 4.8. Gives me 182.4 plus 4.8 squared times 5. I get negative 115.2. I believe I made a mistake. I'm going to double check that. Nope, those are good. Sorry about that. And I'm going to take 182.4 minus 115.2, and I get 67.2. There's the first way to solve that. Okay. So that's how we would do that problem mathematically. You've done those before, but it's been a little while since we did the straight up things. Right? We've been doing, again, the ones that go in an arc, which we'll get to. Okay? The other way to look at this thing is to say, once it gets up to 72.2 meters up here, and we calculated that right here. So the maximum height is 72.2 meters at 3.8 seconds. Well, I want to know where it is at 4.8, which means it's going to, at this point, it's going to fall down for one more second. And we know how far something falls in 1 second. It falls 5 meters. If you aren't sure, remember that's y equals 1/2 gt squared. You don't have to calculate this. Half of -10 times 1 squared. 1 squared is 1. Half of 10 is 5. 5 times 1, 5 meters. Remember, when something falls for 1 second, it falls 5 meters, not 10 meters. When it falls for 1 second, its speed is 10 meters per second. But the distance it falls is 5 meters. So if I know it's at 72.2, and it falls for 1 second, and in 1 second it's going to fall 5 meters, I just need to take 72 minus 5. And I get 67. Okay, so you can do it that way too, just with some logic. Okay, and that's why I gave you 4.8, because it's exactly 1 second from when it was at the top. Hope that makes sense. But if you forget that or you don't see that, this method of using the equation will always work on it. Okay, next part, it says how fast will the ball be going at 4.8 seconds? Again, I don't need to do some big equation. I know it gets up here at 3.8 seconds and comes to a stop. The velocity is 0 for an instant. Once the speed is 0, it then falls for 1 second. Gravity makes things speed up by how much every second? 10. And so if this falls for 1 second, then the speed, oops, sorry, over here with the 67, the v at 4.8 seconds should equal -10 meters per second. It fell for 1 second. We multiply the time by the acceleration of gravity, we get the speed. Okay, let's look at the third problem. We've got an arrow going 54 meters per second. Now we're going to shoot something at an angle. These are ones you've been practicing. You should have plenty of examples of how to do this. But I'll go ahead and walk you through it one more time. Most of you probably maybe had some trouble with the second problem, but hopefully we're really good on the first one and you can do this one on the third one on your own. First thing we're doing is drawing and labeling a vector diagram. So remember, we put the velocity here. It's going to be the hypotenuse of our triangle. I'm going to label this one with the speed, 54 meters per second. I'm going to draw in the horizontal component of velocity, Vx, and in a head-to-tail diagram instead of a point diagram, I'm drawing in Vy. Drawing my angle theta, which is equal to 35 degrees. And remember how we're solving that. This is my angle. Vy is the opposite side of my triangle. Vx is the adjacent side. So I'm going to start off by finding components. Sine theta, let's plug in the angle measure, sorry. Sine of 35 should equal Vy divided by 54. And when I do that, I cross multiply and say that Vy times 1 is Vy, should be equal to sine of 35 times 54. So we'll plug that in. Sine 35 times 54 gives me 30.97. Let's go with just 31. And then we'll do cosine 35 should equal Vx divided by 54. Again, put that over 1. Vx should equal cosine 35 times 54. And I get 44.2. Okay, that's going to be our first thing as we find our components. Remember, the first question is always going to be for you. How long is it in the air? Time in air. Again, we use the vertical component. If I want to know how long it's going to stay up in the air, I use the up component. That shouldn't be too hard, not the over component. So the upward component is the 31 meters per second. It loses 10 every second, so it should take 3.1 seconds to go up, 3.1 seconds to come down. Total time equal to 6.2 seconds. Okay. Second question is always going to be, how far did it go? So I want the, let's call it range, how far it goes. And we said we always use x equals velocity times time. We want to know how far over it goes. I better use the over component. Okay, I want the horizontal distance, therefore I use the horizontal speed and the time I just came up with. So I'm going to have x equals 44.2 meters per second times 6.2 seconds, right here. And that. Multiply those together, 44.2 times 6.2, and I get 274 meters. Hopefully you got that. Last thing is, how high did it go? And again, we take how, let's say high up, and I'm going to change it to how far did it fall? And again, we're going to use y equals 1/2 gt squared. Remember, this thing goes up and back down. We only want the amount of time for it to go down. So I'm going to take my time up here, 6.2, and I'm going to cut it in half. In other words, it takes 3.1 to go up, we said, 3.1 to come down. I only want to use the 3.1 seconds is how long it takes to get from here down to there. Okay? So I plug those in. Y equals 1/2 -10 3.1 squared. You can almost do this in your head. Should be a little over 45 because 3 squared is 9 times 5 is 45. So if we plug that in, 3.1 squared times 5, and I get 48 meters for the height. Turns out to be negative, of course, but remember that's because we did how far it falls. We want to record the positive, how high up is it, but again, I don't care if you write negative or positive for that. Okay, if you have questions, rewind the video, watch those parts again.